the proof for BPT, right? So what does it BPT state? We'll just have a recall. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, parallel thing is important. The other two sides are divided in the same ratio, distinct and same ratio. So that's what we have it over here, right? I have a triangle ABC. Let us consider triangle ABC with DE parallel to BC. So I've drawn this to be parallel, touching AB at D and AC at E. Right, this is what I've done. Next, I will just tell join DE and EC. Sorry, BC. No, EC only. That's correct. Then drop NE perpendicular to AB and DM perpendicular to AE. Okay. So it's not too hard. I'll show you. It's very simple. Then to prove, in this case, it will be AD by DB is equal to AE by EC. So it's very simple. All we have to do is use area of triangle formula. That is half into base into height. Right. Now, which areas should we find? That's the question. So the first one is area of triangle ADE. Okay, so ADE is this, but how do you find it? If I take this as a base, there's no height. But if I take this as the base, DN as the base, half into DN, not DN, sorry, DA. Right? The height will be NE. I know it's not clear. What you can do is you can pause and copy this, like everything of this. If not, open your textbook. I guess it's the same. If not, anyways, you copy this and tilt the diagram. How? I have it over here. So we are looking at A, right? This is the one. ADE, right? This part. Okay. So now if I take this as the base, which one? This as the base. If I take this as the base, this will be your height. That's all I'm telling. Nothing else. You have half into base into height. Next thing is area of triangle ADE itself. I know it's weird, but that's all. The proof is just this. If I take again the area of ADE, the other way around. Okay, the other way around being, okay, let me go back. I'm sorry, I'm doing that too many times. If I take this as the base, AE, so on the same lines, DM is the base, height. To have a look, I'm doing this. You guys can look in your own books. So this is your base and that's your height. As simple as that, right? Base into height. It's just that it's a different perspective. Again, why is that we are doing? The whole point is to get this ratio. So it's almost there, it's not too much. An area of triangle DEB. Now you guys pause and figure out what if I take DE as the base, what is the height? Just tilt your book. Answer is there. Sorry, not DE, DB as the height. Sorry, DB as the base. DB as the base, what is the height? Okay, NE will be your height. So I'll show you that. NE, yeah, this diagram. So what I'm showing here is this. So if this is the base, this is your height. Okay. Right. So you go to basics and see. I've explained how Same thing, I mean, not much, but yeah, I've explained a bit slowly. If this is the base, how is this the height? It's just that it's a perpendicular distance to the base. I know base is somewhere else, but if I continue the base, if I extend the base, this is where they meet, and that's your height, right? So that's your height. Then we have the fourth one, area of triangle DEC is equal to half into, if I take EC as the base, and height is DM. Again, just pause the video and have a look in your own books. So if this is your triangle, that's your triangle, and we are looking at this is your base and this is your height for that. So again, I'm just extending it and right, dropping a height. So for this as the base, that's your height. Okay, and we have what is required. So we'll call this as 1, 2, and 3, and 4. So now, what next? A small statement and we are almost done. Seriously, it's that simple. So what is the statement? Area of triangles between two parallel lines and same base are equal. So areas are equal. Or if you're confused, triangles between two parallel lines and same base have equal area. So where do we have those? See, DE and BC are your parallel lines, and triangle DBE, and DEC. The base is DE, right? So with the same base and between two parallels, we have the area of DEB is equal to area of DEC. Okay, so now what we can do here is, okay, let me clear this up for you guys, then we can continue. Now all we have to do is, therefore, area of ADE by area of DEB will be equal to area of ADE by area of TEC, because ADE area is equal to ADE and DEB is same as the area, same as DEC. So, well, we have equal ratios, same numbers in terms of like values, they are the same. So they are equal. All we have to do now is substitute from equation 1, 2, 3, and 4. So we have half into, so this is where it gets a bit tricky. We have to choose which side and what and stuff. Okay. So I'm choosing the side wherein we have AD and EN. Please look at your diagram. I'm looking at a diagram on my paper and writing all this. And DEB. So here we have DB as the base. Okay, and the height is EN. So you can clearly see half and half, EN gets cancelled over here. So we get the ratio AD by DB. So you're almost there. And next is half into AE into DN divided by half into, in place of AE we have EC into DM. So as simple as this. If you look at your diagram, it's very simple what I just wrote. Half and half, half and half, DN and DN, DN, EN and EN. And now we have AD by DB is equal to AE by EC. right? Since the ratios, hence proved. Very simple, right? Okay, all we did was draw a neat diagram, spoke of area of triangle and found 4 areas, very simple triangles, and equated 2 things, an important statement over here. With that statement, I showed that these 2 triangles have the same area, and we are pretty much done. Okay, so you can pause and have a look at the derivation.